Starting by the first definition, congruent as a word means that two shapes have the same shape and size. The shapes can be rotated, reflected, or translated. So even though each figure here has its own orientation, those figures are considered to be congruent. In this example, we have to choose the figures that are congruent. Starting by this, those two have the same shape but not the same size, then they are not congruent. The hearts, for example, have the same shape and size. Similarly for the arcs, the rectangle do not have the same size, then they are not congruent. The stars also, the remaining two, the arrows, have the same shape and size even though they do not have the same orientation. Similarly for the final figure. If the word congruent means same shape and size, congruent triangles mean triangles with the same shape and size. So the corresponding 6 elements are equal. We take the sides from the first should be equal to the corresponding ones in the second. Similarly for the angles. The triangles as an example, you notice that the first one has 7 centimeters, 5 centimeters, 8 centimeters. Similarly for the second, 7, 5, and 8. 30 degrees, 30 degrees, 65, 65, 85, 85. So those two triangles are congruent. Similarly, they both have equal angles, equal sides. Notice that if we take the first one, slide it all the way here, they are equal. Then how to prove that those triangles are congruent? Starting by the first case, side, 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 we use 3 sides equals the corresponding 3 sides from the second triangle. The remaining ones are 3 angles. Here we use side angle side, SAS. The remaining ones are 2 angles and 1 side. We use 2 sides, 1 remains, 1 angle, 2 remains. Similarly, case 3, angle side angle, we use 2 angles with 1 side, so angle side angle. The remainings are 1 angle and 2 sides. If we take those, we can name them as the homologous elements. Let's start by the first case. The first case implies that if we have two triangles having their corresponding sides equal, then the triangles are congruent. Let's take this as an example. AB here is equals to DE. BC equals to EF and DE equals to AC. 10 centimeters, 10 centimeters, 11 with 11, 12 with 12. If we take the first triangle, slide it all the way. The second, we can notice that they are equal. What we said earlier. First of all, in those two triangles, ABC and DEF, we have those two sides, DE and AB, are equal, both are 10 centimeters. Similarly, CB and FE both are equal, both are 11 centimeters. FD and CA both are equal, each equals 12 centimeters. Then the two triangles are congruent by side, side, side. This is how we prove. Now, moving on to the homologous elements. The remaining elements. We used 3 sides, so then the remaining are 3 angles. So the homologous elements, we notice that this angle equals to angle D. So CAB equals to FDE. Similarly, those two angles correspond to each other. They look alike. Then those two are equal, which are ABC and DEF. Finally, the final one, ACB and DFE both are equal as the final homologous element. Moving to the second case. The second case, we use an angle that's enclosed between two sides, so side angle side. Two triangles are said to be congruent if they have two equal corresponding sides and one angle that's included between them. So we have two equal sides, 12, 11, 12, 11 with one angle between those two. So let's take the first, slide to the second. You notice that both are equal. Write the proof of what we just said. So on that side, those two triangles, ACB and DFE, we have CB equals to FE, both equals to 11. This angle is 60, which is DFE. This angle is 60, ACB. Notice that to the right is the side, to the right is also the side. Similarly, the final one, AC and DF are equal, each equals 12 centimeters. Then those two triangles are congruent by side angle side. Side angle side. Side angle side. The order is important. Let's write the homologous elements. We notice first that this angle corresponds to this one, then they are equal, which is BAC and EDF. Similarly for the second angle, ABC and DEF, those are equal. And finally, the remaining side, both are equal. We used side angle side, we used two sides. So inside the homologous elements, only one side. We used one angle, so the remaining two are in the homologous elements. The third case is angle side angle, a side that's enclosed between two angles. The order is also important. Two triangles are said to be congruent if they have two equal corresponding angles with one included side. So we have those two triangles, a side enclosed between two angles equals to a side that's enclosed between two angles. The corresponding angles are equal. Let's take the first one, slide it all the way to the second. We notice that they are equal. To write the proof for what we just said, in the two triangles DFE and ACB, we have, starting by the first angle, F and C. Those two are equal, both are 60. Then, next to this angle, we have a side, which is FE, equals to CB, next to the angle directly. So FE equals to CB equals to 6 centimeters. So it's angle, then side, then we need an angle. Both angles are 80. ABC equals to DEF, both are 80. Then the two triangles are congruent by angle side angle.